ABM Biotechnology's lead drug should be the first choice for no-option cancer and autoimmune disease for several reasons. First, we have a rapid onset of action and start to see response to our drug within 6 hours and complete responses within 2 to 7 days. So patients can know rapidly whether they need to seek other treatments or options, in opposed to some of our competitors where a patient would be committing for 3 to 6 months of a study. We can directly kill lymphoma and autoreactive lymphocytes by binding to a receptor and causing the cells to commit suicide. From the NIH's Human Proteome Project, we know that that receptor is very selectively expressed only on lymphoma cells, on lymphocytes, monocytes, and neutrophils. So stem cells, red blood cells, and platelets are spared, and the need for transfusions and stem cell stimulation is reduced in these patients. We also know that our drug induces the production of a never-before-described natural killer T cell. Natural killer T cells are a combination of natural killer cells. Those are cells that are agnostic to cancer type. They just like to kill cancer. And T cells, so our cell likes to invade tumors, it likes to kill cancer, and because it has T cell components, it also has long-term memory. We know from compassionate use that's going on in Germany in pediatric, adolescent, and young adult patients that we have medically manageable and transient side effects. So this is a B-cell lymphoma tumor that was implanted in a gel into the flank of a mouse 9 days before we took the tumor out. The dark purple regions are the living viable tumor, and you'll see paler pinkish areas. The animal is trying to kill its tumor, but it is not successful, and within 20 days, the tumors have escaped, and we actually have to take these animals down. So this is a mouse who was implanted with the same tumor. 7 days after we implanted him with the tumor, we treated him with our drug, and just 48 hours later, the tumor is almost completely necrotic. Not only that, but it's just a little over 1/10 of the size. And in the center, where you're seeing like the whiter regions, we already see resolution or resorption of that tumor. So I just want to put these tumors side by side so that you can see them. On the right is placebo without us, and on the left is the tumor with us. And if I was seated in the audience here, I would definitely want to be with us on the right-hand side. So how are we so effective? I mentioned that we induce this natural killer T cell. So we sent tumors blinded to histotox labs in Boulder, Colorado, where they sectioned and stained. And on the left, the red you see are natural killer T cells. And they actually look like little armies. And they're advancing the purple in the middle. They're leaving pink behind them. And they're advancing and destroying everything in their wake. On the right is the red marked cells that are actually committing suicide. So as our army moves through, those cells commit suicide, and then we leave a dead tumor behind us. This is just a whole section of a tumor, so you can see it with the natural killer T cells. On the left is the tumor. 3/4 of this tumor is dead when we took the tumor from the mouse. And the remaining tumor is a combination of pink, dead, but purple, viable. And so histotox labs stained for this natural killer T cell, which you can see on the right, and they overlay the cells. And it's like we have little armies surrounding all of the viable regions of the tumor. And what happens just a little bit later, in a placebo-treated mouse, you can see that dark necrotic area. They tried to kill the tumor, but the tumor escaped. And 20 days later, we had to take that animal down. The tumor's just filled with viable cells. Here's another placebo. Again, tried to kill the tumor, but the tumor escaped. This is what the tumors look like after our compound. They're all necrotic, or already the tumor's being resorbed and resolved. This is another mouse, all dead, necrotic. Another mouse, the same thing. Another mouse, the tumor is dead, black, and also actively being resorbed. Another mouse. So I mentioned that our drug is well tolerated. This is just some mouse data that shows that. Chemotherapy, which can be very effective, it has lots of nasty side effects, causes a really significant drop in body weight, and the body weights from this model are shown on the right, whereas our drug really does not have any impact on body weight in the animals. So if we look at published toxicities and published response rates of our competitors, either approved or in the clinic, toxicities are increasing as you go down, response is increasing as you go right. We're the only drug up there in the top right, which is where you want to be. And that information is from the compassionate use that's going on in Germany. So our targeted market launch is 2023. What that means is revenue to the company. We have the green light from the FDA for an adaptive design master trial protocol, which are very rapid protocols. We had an in-person meeting with the FDA November 5th, and one of the MDs at the FDA actually said how excited he is about our drug. So the FDA is really acting as a partner. The numbers on the bottom, this is a huge market. I don't think I need to put numbers up of what you'll make. But I am very passionate about this. It was 2 years ago that we realized that a drug that we were developing as a preconditioning agent before cell therapy, one of my senior scientists accidentally overdosed our mice. And that's when we got this data that we induced this natural killer T cell, that we have this opportunity in cancer. I'm very passionate because I lost my own son to Burkitt's lymphoma, one of the diseases that could be helped by our drug. And in the pediatric space, these kids are given caveman therapy. And I can't tell you how many MDs have expressed their frustration to me that good and safe drugs that they've worked on have been shelved by pharmaceutical companies and are not available in the pediatric space. This is my team. I couldn't have a better team. I'll be outside at table 6. Thank you very much.